In this video, we will do further problems from exercise 8.3. So question number 10. If vector A, B are unit vectors and theta is the angle between them, show that, let's solve the first one first. Show that sine theta by 2 is equal to half of magnitude of A minus B vector. So let's take what is given here is the magnitude of vector A is equal to 1 and magnitude of vector B is equal to 1 and theta is the angle between vector A and vector B. So let's take the magnitude of A minus B vector and let's square it. So this is for question number 1. So if we square it, we can write this as, from the property we have learned that this is mod A squared plus magnitude of B squared minus 2 times vector A dot product with vector B. Further simplifying this, our magnitude of A is 1 and this is also 1, so it is 1 squared plus 1 squared, and we can write A dot product with B as 2 times, it's minus here, minus 2 times of magnitude of A into magnitude of B into cos theta, as theta is the angle between the two vectors. So further we can say this is 2 minus, we know that magnitude of A and magnitude of B is 1. So it's 2 times cos theta. We know that cos A plus B is equal to cos A cos B minus sin A sin B. So since our theta can be made as theta by 2 plus theta by 2, we can call this as cos squared theta by 2 is equal to, so this is just our rough working here, is equal to, so it's cos 2 times of theta by 2 is equal to cos squared theta by 2 minus sin squared theta by 2. So using this, we can change this as, this is equal to, we can take the 2 out, so 1 minus, so instead of cos theta, we can replace this as cos squared theta by 2 plus sin squared theta by 2. And we know that 1 minus cos squared theta by 2 is sin squared theta by 2. So this is equal to 2 times sin squared theta by 2 plus sin squared theta by 2. So this will be 2 times of sin squared theta by 2. Further, this is on the left hand side, it is mod of A minus B. So if we take the square of both the sides, then square here, we will get the magnitude of A minus B is equal to 2 times sin theta by 2. So further we can say that sin theta by 2 is equal to 1 by 2 magnitude of A minus B vector. Hence the proof. Let's do the second problem now. So again, given magnitude of A is equal to 1 and magnitude of B is equal to 1 and theta is the angle between vector A and vector B. So we can say, let's take the magnitude of A plus B vector, and let's square it. So we will get magnitude of A squared plus magnitude of B squared plus 2 times vector A dot product with B vector. This can be further written as 1 squared plus 1 squared plus 2 times magnitude of A into magnitude of B into cos theta, which can be rewritten as 2 plus 2 times cos theta, which is equal to 2 times of 1 plus cos theta. Now, using the same discussion as our previous problem, this can be rewritten as 4 times of cos squared theta by 2, which is equal to our magnitude of A plus B vector, the whole square. So taking the root on both the sides, you will get magnitude of A plus B is equal to 2 times cos theta by 2. Therefore, we can say that cos theta by 2 is equal to half of magnitude of A plus B vector, hence the proof. Let's do the third problem now. So we can write tan theta by 2 from the previous two results, which is equal to sin theta by 2 divided by cos theta by 2, and putting the values of the first two, we can write this as 1 by 2 magnitude of A minus B vector divided by 1 by 2 magnitude of A plus B vector. So which is equal to magnitude of A minus B divided by the magnitude of A plus B, hence the proof. Question number 11. Let vector A, B, C be 3 vectors such that their magnitudes are A is 3 and B magnitude is 4 and C is 5. And each one of them being perpendicular to the sum of the other two, find magnitude of A plus B plus C vector. So what is given to us is that the magnitude of A is equal to 3, the magnitude of B is equal to 4, and the magnitude of vector C is equal to 5. Now, if we take the square of vector A plus B plus C, then we can write this as vector A squared plus vector B squared plus vector C squared plus 2 times of A dot product with B plus B dot product with C plus A dot product with C. So further, we know that this is equal to the magnitude of A squared, so which is 3 squared, which is 9, plus 16 plus 25, and further we can expand this as A vector dot product with vector B plus vector A dot product with vector B plus vector B dot product with vector C plus B vector dot product with vector C plus A plus, I'm just repeating, they are 2 times, so I'm just repeating them twice, each of them. So further we can simplify this. This would be equal to 15 plus, we can take A and this A here and this A here, and we can say vector A dot product with vector B plus vector C. Similarly, we can say vector B dot product with C plus A plus vector C dot product with vector A plus vector B. So further, we can say that all these items will become 0. Why? Because it says that each one of them being perpendicular to the sum of the other two. So A is perpendicular to the sum of B and C, and B is perpendicular to the sum of C and A, and C is perpendicular to the sum of A and B. So since they are all perpendicular, their dot product will be 0. So your answer is 50 plus 0 plus 0 plus 0, which is equal to 50. Therefore, the magnitude of A plus B plus vector C is equal to the square root of 50. We can rewrite this as root of 25 times 2, which is equal to 5 root 2. Hence the result. Question number 12. Find the projection of the vector this on the vector this. So you have two vectors. So let's define, let vector A equals I cap plus 3j cap plus 7k cap, and vector B equals to 2I cap plus 6j cap plus 3k cap. Now the projection of vector A on vector B is given by vector A dot product of vector B divided by the magnitude of B. So let's find first the dot product of A and B. So that is equal to 1 times 2 plus 3 times 6 plus 7 times 3, which is equal to 2 plus 18 plus 21, which is equal to 41. Similarly, the magnitude of B is equal to the square root of 2 squared plus 6 squared plus 3 squared, which is equal to square root of 4 plus 36 plus 9, which is equal to root of 49, which is equal to 7. Therefore, projection of vector A on B is equal to A dot product with B divided by magnitude of B is equal to 41 divided by 7. Question number 13. Find lambda when the projection of vector A on vector B is 4 units. So given vector A is equal to lambda I cap plus j cap plus 4k cap, and vector B is equal to 2I cap plus 6j cap plus 3k cap. Now the projection of vector A on B is equal to A dot product with B divided by magnitude of B. So substituting the values, we know that this is 4, so that's equal to 4. So let's find the value of A dot product with B, which is equal to, so we can call this as 1, lambda times 2, so it's 2 lambda, 1 times, so this is 6 plus 12, and magnitude of B is equal to square root of 4 plus 36 plus 9, which is 2 squared plus 6 squared plus 3 squared. So which is equal to root of 49, that is equal to 7. So we know that A dot product with B by magnitude of B, you can say from 1, we know this is equal to 4, which means our A dot product with B is 2 times lambda plus 6 plus 12 divided by 7 is equal to 4. So we can rewrite this as 2 lambda plus 18 is equal to 7 4s are 28, which implies our lambda is equal to 28 minus 18 divided by 2, which is 10 by 2, which is equal to 5. So lambda is equal to 5, hence the result. Question number 14, which is the last question in this exercise. Three vectors A, B and C are such that magnitude of A is equal to 2 and magnitude of B is 3 and magnitude of C is 4. And A vector plus B vector plus C vector is equal to 0. Find the value of this. So we are given here magnitude of A is equal to 2 and B is equal to 3 and the magnitude of C is equal to 4. And we are also given vector A plus vector B plus vector C is equal to 0. So rewriting this, we can say vector A plus vector B is equal to minus C vector. Further, squaring both the sides, we can say vector A plus vector B, the square is equal to minus C vector square. Further, this can be written as vector A squared plus vector B squared plus 2 times of magnitude of A into B, dot product of A vector with B vector is equal to vector C squared. So replacing, because the vector A squared is nothing but the magnitude of vector A squared. So replacing, we can further say 2 squared plus 3 squared plus 2 times of A dot product with B is equal to 4 squared. Further, we can rewrite this as A dot product with B is equal to 16 minus 4 minus 9 divided by 2. So our A dot product with B is equal to 16 minus 13, so it is 3 by 2. Similarly, so this is our first result. Similarly, we can rewrite the same given equation, which is A plus B plus C is equal to 0 as A plus vector C is equal to minus B vector. Further, squaring them both, you will get vector A plus vector C squared is equal to vector B squared. We can eliminate the minus with the square. So which is equal to vector A squared plus vector C squared plus 2 times of dot product of A and C is equal to vector B squared. So further, we can rewrite this as substituting the values of A squared, which is 4, plus C squared is 16, plus 2 times of A dot C is equal to B squared is 9. Further, we can say A dot C is equal to 9 minus 20 divided by 2, which is equal to minus 11 by 2. Similarly, rewriting A vector plus B vector plus C is equal to 0 as vector B plus vector C is equal to minus vector A. Squaring both the sides, we can get B vector squared plus C vector squared plus 2 times of B dot product with C is equal to vector A squared. Further, substituting the values of B squared and C squared here, we can say this is 9 plus 16 plus 2 times of B dot product with C is equal to 4. Further, we can say B dot product with C is equal to 4 minus 25 by 2, which is equal to minus 21 by 2. Now we need to find the value of 4A dot product with B plus 3 times B dot C plus 3 times C dot A. So substituting the values of 1, 2 and 3 into this, we can say it's 4 times A dot product with B is 3 by 2 plus 3 times B dot product with C is minus 21 by 2 plus 3 times C dot product with A, which is same as this, as minus 11 by 2, will be equal to 4 times, this will be 6 and this will be plus, so it will be minus 63 by 2 minus 33 by 2. Further simplifying this, you would get 6 minus 96 by 2, which is equal to 6 minus 48, and that's equal to minus 42. That's our answer.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.